Go ahead and get started. So welcome to the Dyer Observatory. This is the last lecture we're going to have before the big event. And it's going to be clear that day, right? Yes. Oh, I hope so. I'm going to be so disappointed. I'm not going to be the only one disappointed, obviously. But has everybody been here before? Who has not been here before? This is always the fun part because it's amazing how many new hands we have up at whenever I ask that question at each event. So. For those of you that have never been here before, welcome, and for those of you that have been here before, welcome back. Let's go ahead and get started. And I think the way we'll do this, we'll hold questions until the end, and we'll have about a 10-15 minute question-answer session at the end of the program. All right, so I'd like to start out with this really beautiful view of total solar eclipse from Norway back in 2015. And I always like to emphasize that this image has not been photoshopped. This is basically what you would have seen if you'd have been out on that ice field with those folks down there. One of the friends of the observatory who actually goes around and chases these eclipses, and he's actually going to be in a jet on August 21st, riding in the shadow. So lucky him. He's going to be well above any clouds there are anyway. He said that in all the total solar eclipses that he's observed, there has never been a picture that he has seen anyway that really captures the splendor and the beauty of a total solar eclipse. So, personally, I think that is an incredible image, but hearing him say that really gets me fired up for this. So for this eclipse, I thought we would break it up into three main sections. We'll talk a little bit about the different types of eclipses, give you some background as to how eclipses occur and why they occur. We'll get some information specific to the August 21st eclipse, especially where you need to be, when you need to be there, and a few other points. And then finally, and most importantly, how to view the eclipse safely. Because after all, we are going to be staring up at the sun. And if you're not careful and you don't know what you're doing, you can easily damage your eyes. And unfortunately, we can't grow new eyes yet, so I'm going to try to fill in any gaps in your information or eradicate any myths or anything like that. Okay? So if anybody has any questions at the end, especially about how to safely view the eclipse, please do not hesitate to ask. If you need me to repeat something, I'm happy to do that as many times as it takes. So here's a diagram of the different types, the two main types of eclipses. At the top we have a side view of the Sun-Earth-Moon system for a lunar eclipse, and then at the bottom we have the diagram for the solar eclipse. And there's a few things that we can really take away from these diagrams. The first thing to note is that the objects and distances are not to scale. The only thing that is in a pretty good scale is the Earth and the Moon. So the Moon is about 4 times smaller in diameter than the Earth. But our Sun, does anybody know how many times bigger our Sun is as compared to the Earth? A million. Well, a million, that's how many Earths you could fit in the Sun. How many times wider? About 100 times wider. All right. The distances are not scaled correctly here. We had to condense everything down. But to give you an idea of how far away these objects are, we have a fun little demo. I had never seen a folding yardstick until I got this demo. Very handy for carrying around in a briefcase or a backpack. But at the 0 of my yardstick, we have a 1-inch Earth. And on this scale, how big would our Moon be? A 1/4 inch. There it is right there on the tip of my stick. Be a little bit hard to see for those of you in the back, so we'll have this model out a little bit later on. Now, if I'm going to place my Moon on this model at the right distance, how far away would I have to place it? Any guesses? Yes? 30. That's pretty far out. Anybody agree, disagree? Raise your hand if you agree. I've got a few brave hands kind of eking up there. So you are correct. On average, this is how far the Moon would be away from the Earth. Okay, a good number to remember, or a good rule of thumb, is that the Moon is 30 Earth diameters from the Sun. Now, how far away would our sun be on this scale? What do you say?
60?
Maybe about 60 inches, okay. Anybody else? What do you say?
About 70.
About 70? Okay, we're gradually getting on up there. It's going to be a little bit more than that. One more guess back there.
100.
100, all the way out at 100 inches, or about 10 feet. It would actually be about 12,000 inches away, or 1,000 feet away. So this room, from where I'm standing to the very back, is right at 60 feet. All right, so that's a pretty far distance, and our sun would be 100 inches wide. Okay, so almost as tall as the ceiling in here. And believe it or not, our sun's kind of a small star too. But that's for another talk. All right, so if we refer back to the diagrams up here, I like to use the lunar eclipse diagram to talk about the shadows, just because it's easier to see that diagram, especially for those of you towards the back. So you'll notice that the moon there is setting within a darker shadow that is labeled the umbra. And outside of that is a shadow. It's actually a single shadow that it wraps around the umbra, and so we've taken a slice through it, and so it looks like it's two separate shadows, but it's actually the same shadow. It's a lighter shadow called the penumbra. The moon in the bottom diagram of the solar eclipse, it has those same shadows. They're just smaller. So if you were standing in the umbra of the Earth or the moon, you would see a totally eclipsed sun. If you were standing in the penumbra, you would see a partially eclipsed sun. So that's going to be really important for figuring out where you need to be on the Earth to see a total solar eclipse, because you need to be in the path of that umbra. And if you look at that bottom diagram of the solar eclipse, you'll notice that the umbral shadow makes a nice cone, and only the tip of that cone is hitting the Earth, which means that tip is not going to be very wide. So the path of totality is not going to be very wide. Okay, and that's what really kind of makes total solar eclipses special. Not everybody gets to see them. Final thing, what phase would the moon have to be in order to have a solar eclipse? It has to be in a new moon phase. What about for a lunar eclipse? Full moon. So at full moon, the moon is rising opposite, and the opposite part of the sky is the sun, so the Earth is basically in between. And so during a full moon, the Earth can cast shadows on the moon. During a new moon, the moon is in between the Earth and the sun, and it can cast shadows onto us. How often do we have those phases? Once a month. Okay, that's how we get the term month, or it's roughly once a month. Okay. How often, on average, is there an eclipse of any type? What do you say?
About 1,000 years.
Okay, about 1,000 years. Anybody else?
50 years.
50 years? I heard somebody over here. Was it you?
Yeah, 2 times a year.
About 2 times a year it's possible to have an eclipse. All right? So let's move. Oh, one thing I didn't show. For those of you in the back that couldn't see the model, there's my Earth-Moon system to scale. So we only have eclipse seasons, or when we have the possibility of an eclipse, about 2 times a year. It's about every 5.5 months. So in this diagram, we have the Earth at the center. We have the moon orbiting around the Earth. And then if you imagine the sun orbiting around us, that apparent orbit, or really just the path of the sun on our sky, is represented by this blue line. And you'll notice that the red orbit is tilted just a little bit with respect to that blue orbit. And that tilt's only about a little bit over 5 degrees. So it's not much. But as a result of that, for most of the new moons, the moon will either be too high in the sky or too low in the sky for it to pass in front of the sun and for us to have a solar eclipse. And likewise, when the moon is on the other side of its orbit, it is typically too low or too high for it to go through the shadow of the Earth. And so we don't have a solar or a lunar eclipse every month because of that tilt. If there was no tilt, then we would have solar and lunar eclipses every month. Okay? So now, lunar eclipses and solar eclipses, they're actually they're tied together somewhat. So let's say we were to have a solar eclipse, and let's say the sun was at this intersection point, at this node, and the moon came around in its orbit and was also at that node. The moon would be in between the Earth and the sun, and it would be able to cast shadows onto the Earth. Now, if the moon is here, how long is it going to take it to get around to this side of its orbit? About 14 days or 2 weeks. In that same time, the sun is going to be moving along this apparent path, and it takes it a full year to get around that path. So in that 2-week period, the sun is only going to move a very small amount on that blue path. So by the time the moon gets over to this side, we're still in basically a straight line. The sun's here, Earth's here, moon's here. And so at that point, we can then have a lunar eclipse. So typically when you have one type of eclipse, you'll have another type about 2 weeks later. And in fact, this year on August 7th, 2 weeks before the 21st, we have a lunar eclipse. The problem is we're going to be on the day side. Asia is going to be on the night side when this happens. So they'll get to see it, but by the time we rotate around, we won't be able to see that eclipse anymore. The moon will have moved out of the shadows. Okay? But we do have one coming for us in 2019. Okay? So eclipses are not rare. Here's a path, or here's a diagram showing the path of all of the total solar eclipses in blue for the years 2001 to 2020. The red paths are the paths of the annular eclipses. Let me show you what those are right quick. Here's a nice image of an annular eclipse. So when we were using the little model, I said on average the Earth is about 30 inches from the moon. The moon is orbiting in an ellipse around the Earth. Okay, so it varies its distance just a little bit. It'll vary anywhere from 28 inches all the way out to 32 inches. It's not a huge change, but that does play a role in our eclipses. If we happen to have a solar eclipse when the moon is at its farthest point from the Earth, it's a point called apogee, or if it's near that point, it will appear smaller to us in the sky. And at that point, the moon will not be able to completely obscure the sun here. Okay? And so for this type of eclipse, you would have to wear protective glasses for the entirety. Right? This is often referred to as a ring of fire just because of the shape of it, but the term annular comes from annulus, which just means ring. Don't get that confused with annual because they do not happen every year. Right? Let's go back to this diagram here. So you can see that for the eclipses, for the solar eclipses, about half of them are annular and half of them are total. And don't be thrown by the really wide paths near the poles. That's an effect of the projection of this map here. Because you notice how Antarctica, even though it's much smaller than Asia, it looks enormous compared to Asia up here. It's just an artifact of the map. Okay? And then for the next 20 years, here are the other paths. And you'll notice in 2024, there is another total solar eclipse that comes up through the U.S. Unfortunately, it misses Tennessee, so we don't get to have every one of them. We have to share. But you only have a couple of hour drive to get from Tennessee over into the path of that solar eclipse. All right? And then here is every path from the year 1001 to 2000. So you can see that most of the Earth is at a point, or every point on the Earth, or most every point of the Earth, is going to be in the path of a total solar eclipse. And given enough time, every point will experience a total solar eclipse. On average, if you're standing at a certain location, you have a total solar eclipse, on average it'll be about 360 to 400 years before another total solar eclipse is visible from that same location. You'll have plenty of partial eclipses. I mean, we had a partial eclipse just a couple of years ago here, but to be in the total solar eclipse path is what's rarer. Okay? The last time that Nashville had a total solar eclipse was actually before Columbus even made it over here to tell Europeans about this new world. Okay, so that was back in 1478. 539 years ago, this location would have been in the path of totality. It'll be at 549 years before we have another total solar eclipse visible from Nashville. All right. So there are many different types of eclipses. We have our partial solar eclipses, our total eclipses, both of which we will get to see on August 21st, again, because there's not going to be any clouds around. We're not going to think about that. In 2023, an annular eclipse will be visible from the U.S. The center of the path won't be here in Tennessee, but it'll be at least a few-hour drive towards the west. But you will have the opportunity to see at least a partial eclipse of that one from here. Lunar eclipses, there are the partials, totals, and then penumbrals. And I'll show you some examples of each of those. Okay, we'll just spend just a minute on lunar eclipses. So this is a sequence of images I took about 15 years ago of a total lunar eclipse. So this first image here, which is the first one that I did take, this is when the moon was in the partial lunar eclipse phase. So it was moving this way in its orbit. This portion of the moon is in the penumbra of the Earth. And so if I was standing on the moon right up here, then I would have observed the sun partially blocked out. But if I was standing down here in this much darker shadow, which is the umbra of the Earth, I would have seen the sun completely blocked out. About an hour later, the moon moved enough in its orbit that it slid down completely into the umbra, and the entire moon would have observed the sun being blocked out by the Earth. One thing you'll notice, though, is that these lunar eclipses, they're not dark. They take on a very red hue. And the reason for that is because of our atmosphere. So our atmosphere is made out of what two main gases? Well, it has carbon dioxide, but it's got nitrogen and oxygen. And unfortunately, the CO2 levels keep going up. But the nitrogen and the oxygen are what are responsible for creating this red hue. So as sunlight and all different colors of sunlight comes through our atmosphere, those molecules tend to scatter the bluer colors. So the violets, the blues, maybe a little bit into the green. The red colors are able to get through much easier. So as you're looking over at a sunset in the west there, as all that sunlight is coming through, we're actually looking through the highest amount of atmosphere when we're looking straight across the horizon. And so this scattering effect becomes very, very prominent near sunrise or sunset, or for moonrise or moonset, or for anything rising and setting. Okay? And so as all that light comes through, the blue basically is completely scattered out, but the red makes it through very well. And some of it will continue on and actually exit our atmosphere on the other side of the planet and continue on out into space. And that's what's happening here. And as the light leaves our atmosphere, because our atmosphere has varying densities, that it also acts a little bit like a lens. And so that light gets bent just a little bit, and that causes it to go towards the moon a little bit more. And so all of this red light is just a result of our atmosphere. If you were standing on the moon looking back at the Earth during the total lunar eclipse, you would observe every sunrise and sunset all at once. Okay? So you'd see a silhouetted Earth surrounded by this bright orange ring. The penumbral lunar eclipse, not very dramatic. In fact, if you didn't know they were occurring, you probably wouldn't notice it. All right? So this is just a regular full moon, and then this is a really good penumbral lunar eclipse. So you can see this portion is shaded just a little bit. So now on to the solar eclipses. So everybody in the continental U.S., in fact, everybody on the continent of North America will have an opportunity to see at least a portion of the sun obscured on August 21st. This was about a 35% coverage here. Most of the U.S. will see about at least 75% of the sun obscured on August 21st at maximum eclipse. Now, if you're in the path of totality, Nashville is the largest city in the path, then you will have an opportunity to see the total eclipse. So when the moon completely blocks out the disk of the sun, this beautiful corona becomes visible. So this is the outer atmosphere of the sun. The only time you can see it is during a total lunar eclipse. There isn't a telescope that will show you this. All right? So this outer atmosphere is about 2 million degrees Celsius. It's very, very thin. It glows in visible light because it's actually reflecting sunlight. All right? It actually glows prominently in X-rays, but it will reflect sunlight so that we can see it with our eyes. This is only about as bright as a full moon. Very, very faint. So if any portion, or if even a small portion of the sun's disk is visible, that completely washes out that corona. So you can really only see this just a few seconds before totality all the way through to a few seconds after totality. You'll notice that there is structure in this corona. There's these very fine lines coming up here. This image has been enhanced to really bring out those fine details. So you'll see some structure in the corona, but you probably won't see quite this much. Right? So this was a view from Australia in 2012. So these beachgoers had a really nice day at the beach getting to observe this, this total eclipse. This is a really famous view from 2003, a total solar eclipse visible in Antarctica at sunset. But this one, you'll notice you can really start to see some large-scale structure in the corona. It's not an even like haze around the sun. So you could expect to see maybe a little bit of structure like this on August 21st. Now, if you were standing on the moon looking back at the Earth, you would see the shadow of the moon crossing our planet. So this is obviously a time-lapse view, but it takes a few hours for that shadow to go completely across our planet. It's moving about 2,200 miles per hour across the planet. Notice also that our Earth is rotating in the same direction. So our rotation helps to keep us in the shadow a little bit longer than if we were just sitting still. So right now, because of our latitude, we're moving at about 700 miles per hour just due to the rotation of the Earth. And that'll be important for determining how much totality you'll get to observe. All right, so some of the details of August 21st. So again, all of the continental U.S. Will get to see a partial eclipse. Most of the U.S. is only going to see the partial, but there is a 75-mile wide band that goes from one side of the U.S. to the other. And that's the path that you have to be in order to see that total solar eclipse. We happen to be the largest city in the path. And if you're in a really good spot, such as Gallatin or Hopkinsville, you can see about 2 minutes and 40 seconds of totality for this particular eclipse. And there's a lot of factors that go into determining how long of totality you'll have. The distance of the moon, our distance from the sun, your location on the Earth, all these different factors play a role. So I've mentioned some of these numbers before. This will be the first time a total solar eclipse has been visible from one side of the U.S. to the other in 99 years. So back in 1918, there was a total solar eclipse that followed a very similar path, but going back almost 100 years, we didn't have the really large infrastructure that we have nowadays. And so this total solar eclipse, going from one side of the U.S. to the other, will be accessible to many people. In fact, 80% of the U.S. population lives within a day's drive of the path of totality. This will be the first solar eclipse total solar eclipse visible from the continental U.S. since 1979. That one was visible up in the northwestern part of the U.S. and actually went up into Canada. And the first time that U.S. soil has experienced totality since 1991. So that was actually, anybody know where that was at? Where that path of totality was visible from? Wasn't Alaska, good guess. Hawaii. So the shadow actually went right over where the big telescopes were. But big telescopes aren't made to look at the sun. But at least one large filter was fabricated for a telescope to where they could view that eclipse. Okay. What to expect during totality? So the sky is going to darken. Let's see, what time is it getting to be? So probably in about 30, maybe 40 minutes. If you go outside, look at how dark the sky is. That's what you can probably expect during totality. The temperature may drop anywhere from 10 to 20, maybe even a little bit more degrees Fahrenheit. Animals, especially birds, have been noted to behave differently. Roosters are known to crow during totality. Actually, you'll have to, where is Ken? Is he in here? There. So Dr. Garrison back there, he was telling us about when he was observing an eclipse from Nova Scotia on one of the bluffs overlooking one of the sounds, how as totality was just about to hit, and during totality, all of the seabirds were coming in because they thought it was nighttime. And then once totality passed, they went right back out. So, yeah, so be sure to ask him about his experience back there. You'll see some features of the sun that you normally can't see, especially that corona, and maybe some things called prominences. I'll give you an example of what those are. And then finally, planets and stars will become visible to the unaided eye in the middle of the afternoon. So here is a really nice animation put out by NASA, and this is on our website. In fact, all of this is on our website, just showing the path of that shadow across the Earth. So you notice that the shadow hits Salem at about 12:10 our time, goes through Casper, actually just grazes Kansas City and just grazes St. Louis. And literally the northern part of the city is out of totality. Southern part of St. Louis is in totality. Nashville's in it, Charleston's in it. It only takes that shadow about 92 minutes to get across the U.S. here. Okay? So again, it's moving about 2,200 miles per hour, but because of our rotation, it's moving about 1,400 miles per hour relative to the ground. We're about twice the speed of sound. So here's that path again. One thing that we've been trying to stress to folks is that you can't just be near the path of totality to see the total eclipse. You have to be in that path. If you're near the edge, 1,000 feet may make all the difference. So the blue line represents where you'll have the longest duration of totality for different portions of the U.S. So greatest totality actually occurs right around here. Totality over in Salem will be a little bit shorter just because the Earth is curving away from the shadow. So those folks will be a little bit farther away from the moon. The moon will appear smaller, and so it won't be able to obscure the sun for quite as long. So there are NASA sites and sites like GreatAmericanEclipse.com that have maps for every state that the path of totality crosses. You can get them in higher resolution. So we'll zoom in on Tennessee. So again, you have to be at least on or within these bright purple lines here. Right. So you'll notice the different times here. So maximum totality is going to be right along the center line. So folks in Gallatin, they'll get about 2 minutes and 41 seconds of totality. Downtown Nashville gets about 2 minutes. You guys are sitting, let me see if I can get my laser just right. You guys are sitting right about there. And if you were here on August 21st, you would have 1 minute and about 10 seconds from the observatory. Which, by the way, we're not doing anything here. We're not going to be open because we can't fit many people up here. We only have a limited totality. And our big telescopes can't view the sun. Okay? So you don't need to be up here. So do not come up here. You will not get through the gate. Okay? Please don't try to go around the gate either, okay? But now, if you went from there, just literally a couple miles down this way, you would be at about 1 second of totality. The point to take away from this is if you're near the edge of totality, it really benefits you to move just at least a little ways towards the center because you will dramatically increase your time. So again, this purple line here, you see how it crosses I-65? That's actually where Concord Road hits I-65. So that's exit 71 down there, and we're right even with exit 74. So going from there to here, I go from a second to a minute of totality. And then going from there to there, I gain another minute. But again, if I go from here all the way up to here, I only gain about 40 seconds. So if you're already pretty well near the center of the path, don't worry about moving around. Also note that that path goes right over a bunch of interstates, and especially where those interstates intersect. Traffic is likely going to be at a standstill that day. So the last estimates that I've heard are at least 1 million people are coming into Nashville for the eclipse. You know how bad rush hour is with our normal population. If you're going to go to a friend's house or to a relative's house, don't say, oh, I'll leave a couple hours early. You're not going anywhere, more than likely. Right? Do it the day before, or maybe get up before sunrise and do it. Give yourself plenty of time. There was actually a really good article in Newsweek where they spoke to some different folks, like emergency management and some other folks. But one thing that they recommended was if you are going to be traveling that day, be sure to have food and water in your car, because you may be stuck on the interstate for hours. You may be there all day. And it's going to be hot. You don't want to be stuck there and not have any water or anything. So treat it kind of like it's a disaster, because you're going to have a tremendous amount of people really straining the resources of the area. They also interviewed one of the spokespeople for Verizon. They have a lot of towers around here, and they're expecting that the cell network is basically going to be a big clog that day. They recommend if you're going to be going anywhere, literally print out the map, because you probably won't have any data. You probably won't be able to make calls. So just think about those things. We may be blowing it out of proportion. You never know. You just got to be prepared for these kinds of things. So for Nashville, there are some important times. Now, if you were, for example, in Clarksville, about 60 miles or 50 miles northwest of Nashville, you'd move these times back by about a minute. But first contact, so if you are looking up at the sun with your solar glasses, you see a big disk in the sky. At about 11:58, that's when you first start to see the moon moving in front of the sun. Anybody get one of these sheets yet? We have lots and lots of these sheets out front, so everybody be sure to pick up one. One side has eclipse information, the other side has viewing information, but we've got these times on there. And again, it's on our website, and I'll also show you a website to go to get your personalized times for your location. Okay. So second contact, about an hour and a half later, that's when the moon has finally moved completely in front of the sun and we have totality. For Nashville, that's only going to last about 2 minutes. It's not going to be at exactly 1:27, and in fact, the times that you will get on these websites will have an uncertainty of a couple of seconds, because there are so many factors that go into calculating these times that, varying just one by a tiny amount will affect your time. So be ready by about 1:27 for totality. By 1:29 for Nashville, the moon has finally moved enough that it starts to uncover the sun, and about an hour and a half later, by 3 p.m., the moon is completely out from in front of the sun. Solar eclipse is completely over. So it's a span of about 3 hours. The time you're going to need to use those glasses, those eclipse glasses, where did I put them? Oh, here they are. These glasses here. So we have these available tonight, but because we have limited supplies, we have a limit of 1 per family. You only need 1 per family because you have an hour and a half to use the glasses to view the partial eclipse. You'll take them off during totality. You have to take them off during totality. Did everybody hear me? You have to take them off during totality. If you have them on when the sun is completely blocked out, you won't see anything. Literally, you won't see anything, and you will be kicking yourself because you will have missed the big event. But then, when the sun begins to reemerge for another hour and a half, you'll have these back on, watching the partial eclipse. So when any part of the sun's surface is visible, you have to have the glasses on. But again, you have about 3 hours total of partial eclipse. So that's plenty of time to pass these around. You can put your phone up to them and take a picture through them. So you don't need one for everybody, okay? But we'll talk about those glasses in just a second. So again, here's that 2015 eclipse in Norway. I don't know if you can see the little spot right there, but that is the planet Venus. This map is also available online. It's on this info sheet. But this is a computer simulation showing where things will be located in the sky on August 21st. Now, when you use one of these maps, you'll notice that the west and the east are backwards, okay? Because you're not reading it like a regular road map where you're looking down like this. You have to hold this up to the sky, okay? So if you imagine lying on your back with your head towards the north, which is that way, west is going to be over there, east will be over here, south will be at your feet. So during partial eclipse, as you're passing your glasses around, look at this map, figure out where your directions are, and say, okay, there's west, about 2/3 of the way up, Venus is going to be right up there. Okay, so there's Venus. Over in the southeast, about halfway up, we'll have Jupiter. Okay? Mars and Mercury will be right around the Sun. They'll be fainter than Venus and Jupiter. Jupiter and Venus will appear like really bright stars. Right? And you may be able to see a few true stars like Arcturus or Capella, maybe even Sirius, depending on the sky conditions. One thing that's not really shown well in this is that the horizon is not quite that dark. You'll see illumination all around the horizon. Some folks liken it to a sunrise all around, but not quite as orange as a sunrise. Okay, so it's not going to get like midnight during totality. Again, it'll be like about 8:15 at night. So some features to look at on the Sun. So again, this is when the Sun's surface is completely obscured. That's the dangerous part. The corona, that is perfectly safe to look at naked eye. So again, you're not going to use those solar glasses when this is visible. You may see some little pink tufts sticking off the edge of the eclipsed Sun. And those are known as prominences. Here's a closer up view over here. These are large clouds of gas that are being lofted up by the magnetic field of the Sun. They look very small. They're not going to be quite that vibrant. They're going to look small, but like that cloud there would be several times the size of the Earth. Okay, but you're seeing them from almost 100 million miles away, so they're going to appear small. If you're near the edge of the path, you'll often see this phenomenon during totality. These beads, named after Sir Francis Baily, who was really the first one to really report about them, these are little tiny bits of the Sun's surface poking through the valleys in between the mountains on the edge of the Moon. Okay, so the Moon has a very irregular surface, and so you may be able to see those beads. And again, this really is typically visible, near the edge of the path. Now, if you're much closer to the center, or just a little ways away from the edge of the path, about 5 seconds before totality till about 5 seconds after totality, you'll see this effect. So this diamond of the diamond ring is just the first bit of Sun, in this case, it's just about to disappear. And now, since you've got just a very, very tiny amount of the Sun's surface shining through, which is still incredibly bright, it's not bright enough to completely wash out that corona. And now the corona becomes visible just a little bit. In fact, right there's a little prominence sticking off the edge. So the Moon is moving this way, and so this was just a few seconds before totality. Then once that disappears, the corona becomes easier to see. And then as totality is ending, you'll see a bright spot start to emerge over here. And then, about 5 seconds after it starts to emerge, it is now bright enough that it will wash out that corona. All right. You should not stare directly at that bright spot. To see this effect, you'll have to take the glasses off, but just don't stare at the bright spot. The solar glasses, what's important about these is that they block out all of the ultraviolet and the infrared light. What makes eclipses really solar eclipses really dangerous is that folks now have a reason to look at the Sun, because it's becoming this crescent shape. They try to find something that will dim down the Sun to where they're not looking at this incredibly bright spot in the sky, and they're squinting, they're tearing up. You can't stand there and stare at it. These reflexes keep making you avert your vision. But if you find a filter that is not sufficiently protecting your eyes, you'll dim down the visible light, but you're still letting a tremendous amount of UV and infrared into the back of your eye. And so you're standing there staring, and the whole time the back of your eye is literally being burned. All right? I mean, literally being burned. There have been 2 people that I've spoken to in the past 6 months or so. One was an ophthalmologist, and one was a patient of an ophthalmologist. The ophthalmologist has seen people that have stared at eclipses with the wrong filter, and he's actually seen the crescent-shaped burn on the back of their eye. And then the guy I was talking to that was the patient, he has a crescent-shaped burn on the back of his eye. So when you damage your eye like that, you'll get really blurry or basically no vision right in the center of your field of view. Right? And you may not get that immediately. It may take a little while for that to become apparent to you. Some people will recover a little bit from it. Some people still have that eye damage today. So that's the important thing, is make sure that your filters are blocking out this infrared and this ultraviolet. Okay? So these glasses will do that. We just put something on the front page of the website that came to us via an NPR article. These glasses are becoming harder and harder to get. American Paper Optics in Memphis, I think they printed 65 million of these. I mean, they were at full capacity. They've stopped taking orders. Rainbow Symphony is another one that does it, and I don't know how many they've produced. So people are now starting to try to cash in on this, because now people are really getting desperate. They want these glasses, and they're making glasses that do not protect your eyes. And so the American Astronomical Society has started compiling a list of reputable vendors. And on our website, on the front page, we've posted a link to that list. So if you're going to get these glasses from somewhere, make sure that you check that list first. But the main thing that is apparent to people with these counterfeit glasses is that the sun is incredibly bright through them. You should be able to put the real glasses on and look at it, and it just looks like a dull light bulb. Okay? You have no problem looking at it whatsoever. Right? If you get those glasses, do not do that. So this is an unfiltered telescope. I did not point it at the sun, but if I had, all of that light, even though this is a pretty small telescope, the lenses would have focused that light into an incredibly bright spot on my glasses, and it would literally melt through in just a couple seconds. And then it really starts to burn your eye quickly. Not only are you now burning the back of your eye, but you're burning your cornea, your lens, your iris, anything in the way. Another safe way to view is using a number 14 welding glass, and that's the number you really have to keep in mind. You can get a number 15, that's even better, but a number 14 blocks out the infrared and the UV. So I've got a sample up here, and I've even got one that I've mounted in a box top, so that the box top kind of protects the glass. It also makes it allows for it to really cast a shadow on me, so I don't have a bright glare around this. But you're welcome to come up and look through them. These tend to give the sun a very green appearance, and it's a little bit brighter than what the glasses will show, but it is safe. It's a number 14. Local hardware stores, we found, typically don't carry that shade 14 in stock. Welding supply stores might, but look online if you need them. And they're only a few bucks. If it is cloudy that day, and we've all seen the sun through thick clouds, and it looks like this nice little orb, really do not stare at that, because infrared and ultraviolet still get through very well. If you've ever been working outside in the yard on a cloudy day, you still get a sunburn, okay, because the ultraviolet's getting through, and the infrared will also get through. Okay. This was a picture from the 2016 eclipse. Yeah, so this poor guy probably has crescents on the back of his eyes right now. So even if these are supposed to be 100% UV protective, that's not for looking at an incredibly bright source like the sun. Okay, it'll protect you from the ambient light, but not the really bright point source. One of the older ways to do it was to get exposed X-ray film or exposed photography film and look through it. But again, it's the same issue. It's that infrared and that UV. Okay, so it may get really dim, and you may not be squinting at the sun, but you're still getting a massive dose of infrared and ultraviolet. Smoked glass was another way that folks used to do that, but again, that's just as dangerous. We recommend that if you're going to do any type of telescopic viewing, only do the partial eclipse. And you can get solar filters that are made for different telescopes. These are made to where they fit very snugly onto the front. Some of them even have set screws on there to where the filters can't fall off. These filter the light before it enters the telescope, and that's the thing you have to do. All right? If you try to filter the light after it's going through the telescope, like, let me find it here, like this type of filter does, these types of filters are screwed into the eyepiece, and so they take the brunt of that incredibly focused bright light, and they are notorious for shattering. And I've still found these online. You should never ever use one of these because they fail almost 100% of the time, okay, or close to that. If you have a telescope and you're not afraid of possibly damaging it, or maybe you just go to a local hobby store, just pick up a little dinky telescope for 20 bucks or something, you can project the image of the sun through an unfiltered telescope. Here's the eyepiece of it up here, and it projects down onto a projection screen. This will not reflect a whole bunch of UV and infrared towards your eyes, so it's safe to look at. And the nice thing is you can get a whole bunch of people around it at once looking. But if you do that, make sure that you set it up so that somebody, especially a small child, can't come by and look up into that eyepiece, because they'll get all of that incredibly focused light there. You could also use the pinhole projection method. So this person over here was using a colander, and you notice, and maybe harder in the back to see, but every hole is an image of a partially eclipsed sun. You can also take just a piece of cardboard, punch a little hole in it, maybe about the size of an eraser head, or just take your pencil and jab it through and make a small hole. Hold your cardboard out, let the sun shine through it, look at the shadow on the ground, and you'll see the light coming through that hole is in the shape of the eclipsed sun. This won't really work through totality, though. Okay, once totality is occurring, look straight up at it. If you're going to be doing something like this, make sure that everybody knows, you don't take the cardboard and look through the little hole, because especially like little kids, they may think, oh, I looked through this tiny hole, and this cardboard is helping to block out the light. That's not how you do it. Okay. Also, look around at the trees. So this was just a little bit before totality, but you'll notice that every little bit of light coming through the gaps in the tree leaves and the holes in the leaves themselves, they act as little pinhole viewers. So you'll see all of these images of the eclipsed sun. So to wrap it up, these are, again, the main points we want to get across. If any part of the sun's surface is visible, and we're not talking about the corona, that's the atmosphere, but that bright surface, you have to have those solar viewing glasses on, or you have to have the proper filters on your telescope or whatever. So 1% of the sun's surface is literally 10,000 times brighter than the full moon. That's a lot of light being put out by that tiny little bit of surface. And so you have to have eye protection on, even if just a very, very thin crescent of the sun is visible. Once that last bit of crescent goes away, then you can take the glasses off and look at totality. And again, when you're in totality, when the sun is completely blocked out, you have to take those glasses off, because the glasses will completely block out all of the corona. This is safe to look at. And then once that little bit of sun starts to re-emerge, put your glasses back on. Now, if it does end up being cloudy, like it was in Shanghai in the 2016 eclipse, you'll still experience totality. So this is just before totality, and then that's during totality. So it's going to get, if it's really cloudy out, it'll get incredibly dark during the middle of the afternoon during totality. Okay. But we're not going to worry about clouds. Oh, the point I forgot to mention. So if you are using a telescope looking at the partial eclipse, maybe you want to take pictures with your camera through the telescope, that's fine and dandy. During the total, did I say partial eclipse? Yeah, so only use the filter during the partial eclipse. During totality, though, it is not recommended that you then pull the filter off and look through the telescope. You're not going to get that much of or not that really good of a view. But the main thing is you don't know the exact moment that the sun is going to start to reappear. And even that tiny little bit of sun, when viewed through a telescope that literally gathers, maybe over 1,000 times as much light as what your eye can gather, that tiny little bit is going to instantly damage your eye. So you should not do that, okay? Don't worry about trying to take pictures during totality. You've only got a maximum of 2 minutes and 40 seconds to look at this. Just put your phone down. You're not going to be able to call anybody anyway, probably. Just stand there and take it in. Then look around the sky, see what you can see. If you want to try to get a picture, let somebody else who's really good at taking the pictures, who has done it before. It's actually pretty hard to get a good picture during a total solar eclipse because you've got bright parts, you've got faint parts, You've got to take multiple exposures. You've got to make sure it's focused right. Let them waste their time. You know, you take it in and then get the picture from them. Okay? And all the pictures, they'll look pretty much the same. Okay? All right, so we'll do a question and answer session. And I think we have a microphone. But yes, saw your hand first.
Who's talking?
You guys got to use a microphone.
Yeah, I'll repeat it. Hold on. So during totality, it's going to get pretty dark out. So if you look at how dark it is out now, Ken, would you agree that that's about correct level? So again, it's not going to be like 10 o'clock tonight, but
Do we know why animals act differently?
do we know why the animals act differently? They have no idea what's going on. They don't realize it's the moon going in front of the sun, and so they think it's just nighttime. So it's just a short day for them, it seemed like, or they're like, where'd the time go? So, and you had a question, yes?
On some of the other slides, you had different types of eclipse, but you had the hybrid eclipse, and you never spoke of that.
Yes, thank you for pointing that out. So the hybrid eclipse, yes. Yeah, I pointed out in blue the total eclipses here, in red the annular eclipses. But if you notice, there's also this hybrid eclipse, and it's given by a fuchsia color. So you notice this eclipse right here is a very, very, very thin line. So notice that line is blue here, and then it becomes that fuchsia color here, and actually it continues on and it ends in red over here. So a hybrid eclipse is a special occurrence where the distances are basically just right, that your position on the Earth really makes the difference between an annular eclipse and a total eclipse. So in this case, if you imagine that you all are the sun shining light to me, my fist is the moon, and my chest is the Earth, somebody over on this side, on my side here, they're going to be just a little bit farther away from the moon than what people on the front of my chest are going to be. They're going to be about 4,000 miles farther away. And if the moon is at just the right distance, these people over here will see the moon just slightly too small to cover the sun. And so they'll see an annular eclipse. Then people over here, as the shadow comes across, these people over here are an Earth radius closer. They're 4,000 miles closer to the moon. The moon appears slightly larger to them. And so for them, the moon is large enough to completely cover up the sun. And so they see a total eclipse. But if you're over here, you see the annular. And so that's all a hybrid is. Oh, right behind you there.
Do you know if any kind of community outreach is going on to teach people who might not have access to this kind of a program to tell them about safety? Lower income communities or other such outreach?
The only outreach that I'm really familiar with is what Vanderbilt has been doing. So we just had to stop advertising because our schedules are full now, but we've been advertising doing free talks to groups around the area. It didn't matter, if you're a college campus or a retirement facility or whatever. If you could get a group together, we would come and give a free presentation. We were working with the physics and astronomy department to get all of the grad students, postdocs, and faculty out there to help as well. And they're actually doing a lot of presentations as well. So I've still got, let's see, I think I have about 16 talks left to do between now and Eclipse Day. So yeah, my schedule's getting pretty full. So we're kind of running at full capacity, and that was our main goal, was to try to educate people as much as we could so that they knew where to be, how to view the eclipse safely, and whatnot. Yes.
Are you familiar with the app Solar Eclipse Timer?
I am not familiar with the app Solar Eclipse Timer. Should we get it?
It's supposed to for $1.99.
For $1.99, okay. Okay.
Or you can turn on and it
Okay.
will give you an auditory notification when first contact, second contact.
Okay.
Yeah.
So for folks that didn't see or hear that, what was it called again? Solar Eclipse Timer? Okay.
This is for here. But
Okay.
if cell phones aren't working.
Yeah, so the thing was, so there's an app called Solar Eclipse Timer that will give you audible alerts based on your location of when first contact, second contact, third, and fourth contact are. I have not tried that out, but thank you for letting us know about that. But that also gave me another cue I forgot to mention to you all. So here's, oh, hold on. So here's the front page of our website. And here is the little notification about the possibility of getting fake solar glasses. And we've got the list that the American Astronomical Society has been working on. And it's still a growing list. But again, just check whoever you're going to be getting the glasses from. See if they're on that list. And you'll be good to go. But if you were to click on this banner, you'll go to our Solar Eclipse page, which is this one here. It's got all of this info, images. So if you want to download one of the movies or read, maybe I talked about something and it didn't quite sink in, check this out. But there is a link section down towards the bottom. If you find the sky map here, it's right under that. There's a couple of links for Google Maps. And this bottom one I particularly like. It'll typically take about a minute or two to load, but it shows the path of totality. You can click on there and, oops, I did that wrong. Am I doing it right? Yeah. So I'm going to type in the observatory's location. There we are. Click on that, and it'll zoom in. Let me zoom in for you guys. All right. So it will calculate based on your location how much totality you have. There's two times. This bottom one, this lunar limb corrected, this is where the algorithm is trying to take into account all of the features of the moon as well, okay, which will affect your amount of totality. Notice it's not a huge change here, but they do try to take into account everything. Yes. Yeah. Yeah. So, I mean, there's been a lot of work going into these models. You've got start time of partial eclipse, start time of total, end of total, end of the partial eclipse. Notice, though, that the times are in universal time. So if you're in Tennessee, if you're still in the central time zone, and, you know, we're in daylight savings time, we'll still be in daylight savings time during the eclipse. But if you're in the central time zone, subtract 5 hours from this. So the start of our eclipse would be 18 minus 5 is 13:27, which is 1:27 in the afternoon. Okay? So that again is on our website. And there's also, I think, some NASA pages as well that will try to give you times based on your location. I think we had one of those hands up first back there.
How many times has the solar eclipse happened?
How many times has the solar eclipse happened? Well, let's see. We've had a moon for about 3.5 billion years, and it happens about twice a year. So I would say at least a couple billion times, but give or take a few. Yes, and the person right in front of you, do you want to hand her the microphone? Oh, thank you. Sorry.
Is there a particular spot where you suggest viewing it in Nashville, Tennessee?
Good question. Let me go back to that. Let me go back to my presentation here. Go back here. There we are. Let me find our map. Now, pretty much, every city in the path of totality is going to be doing something that day. Nashville has an eclipse page. I think it's Music City Eclipse, but just Google search it, and they have a list of the events that they know of that are going on downtown. So downtown's going to be really crowded that day. So if you're planning on going anywhere, I probably wouldn't head downtown, but you'll have a lot of fun, okay? You may have a long time, you may have to walk there, but you'll have fun. So, you don't have to be in any particular, big city. Like, for instance, Lebanon over here, I mean, they're getting pretty close to the center of the path. Carthage, actually where I did my first talk about the eclipse, it's located right in here. I mean, they're smack dab in the center. But as I was driving out there, it took me about 40 minutes to get out there. I was going through a lot of countryside. So, if you just went anywhere in this path here, you'd have some of the best views of anybody. It doesn't have to be in a city. If you're going out here and you take one of these little side roads, just go on down, just make sure you have your map so you know how to get back home. Just, find one of these areas in here. Maybe there's a big shopping mall parking lot you can park in and just kind of set up camp there for a few hours. Speaking of malls, so Franklin, they're right here. They're just outside the path, and Cool Springs is right there as well. So they're just outside the path. So don't plan on going down to the Cool Springs Mall that day, because you'll be disappointed. Okay. Yeah, I can or he's got the mic coming on around.
Thank you. The shadow bands or snakes, can you explain that?
Shadows, yeah, so I think they're technically called shadow bands. So when you are nearing totality, it usually starts about a minute out of totality when the sun is getting to be this really, really thin crescent on the sky. As the moon continues to move, that crescent doesn't only get thinner, but the edges start to shrink down. And as you get more and more of a smaller and smaller crescent, the sun is becoming more and more of a point source. And for a point source, it's very easy to scatter the light with the atmosphere. If you have, let's say, a bright white building or the white side of a car, as totality is about to occur, that point source in the sky is now starting to really be bounced around by the atmosphere, and you're going to see these waves forming on the side of the vehicle or on the side of the car. And that, again, it's just because of that point source. It's the similar effect to the bottom of a swimming pool where you have all the waves going. They won't be that apparent, but you'll see this waviness in the air. Okay, so it's also kind of like when you're looking down a very, very hot road in the summertime, you can kind of see how the road is waving. It's the same kind of effect. But yeah, it really becomes apparent when you get that point source. So starting about a minute to about a half minute, you really begin to notice it. And there are a lot of YouTube videos about that. So check them out. Anybody up right here?
Just before and just after totality, is it safe enough to look off to the side of the event and just have it in your peripheral?
Yeah, I mean, it's kind of like whenever the sun is out and maybe there's a really nice cloud in the sky or something like that. You can look at the cloud, just don't look directly over the sun, so you're not getting that full blast of radiation on the back of your eye. So by that time, I mean, the sun's going to really be diminishing in its brightness. And so, and again, that diamond ring only lasts for a couple of seconds. So also in that, and you can look on NPR and see the article I was talking about safe solar eclipse viewing. There was a doctor on there that said, people say, well, what about taking these very quick glances over at the sun? And they said, and he was saying, yeah, it doesn't really do damage that much, but you keep doing it, those little glances really start to add up. Okay, so you just kind of have to, use your common sense and don't just sit there and stare at it, or, just use your best judgment, not common sense, but your best judgment on that. Okay. Yeah, he's got it there.
When you're looking through the filtered glasses, is it obvious when it's total? Do you wait until it's total black, or can you really see the eclipse?
So you're not going to see any of that corona through those glasses.
Okay.
All right. You're going to see the just a few seconds before totality. You're going to see that crescent is super thin, and the edges of it are shrinking down towards one another. And by that time, anybody else that's around you, they're going to start hooting and hollering because they're going to start seeing that corona. So for me, when I see those edges really shrinking down, I'm probably just going to take the glasses off. I'm not going to sit there and stare at it, but I'm going to get ready to see if I can see that diamond ring out of my periphery, and then try to observe.
Obvious through the filtered glass.
Yes. So once the sun completely goes out, you're not going to see anything. Okay. Oh, right, yeah. We got one in the back there.
Why is it called the eclipse?
Now we're getting into etymology. Is that the correct term? Yeah. I'm not sure why it's called an eclipse. Dr. Bob, you want to take that one? If I don't know the answer, I go to Dr. Bob. He knows all the answers. I would say it's probably a Latin word, and I have no idea what the original term means, but it's safe to say nobody's ever asked me that before, and I don't know the answer to that. Yeah.
When's the next total solar eclipse going to happen?
So the next total solar eclipse that'll be visible in Nashville will be in 549 years. So I'm probably going to miss that one, unfortunately. But let's go back here. We've got our eclipse map here. And again, these are put out by NASA. But the next total solar eclipse that you'll be able to see here in the U.S., you don't have to travel halfway around the world to see, but you will have to travel from Nashville to see it, is over in 2024. Okay, so just about 7 years from now, a little less than 7 years. It's in April of 2024. Now, the nice thing about that eclipse, notice that band right there is a little bit thicker than our band because the moon is physically a little bit closer. It's bigger in the sky. It can obscure the sun for a little bit longer. So that one you'll have about 4.5 minutes. The other thing to note, if I keep flipping back and forth in these images, notice how those bands intersect. That's right over Carbondale, Illinois. They're in the path of both of those eclipses. Oh, okay. So, yes, so the eclipse, it's the Greek word to leave. So now everybody knows. Thank you. That's a good Jeopardy question, right?
You have a question?
I don't want.
Ask him. She's asking who made the sun, the moon, and the stars.
The sun, the moon, and the stars. That's a pretty complicated question. We'll have to probably save that for another time. But another good question I have not been asked.
How far can the eclipse go around the world?
How far can it go around?
How far can the eclipse go?
So the shadow of the moon, it'll sweep completely across the face of the Earth here. So you notice, so there's the shadow of the moon from the 2016 eclipse. Notice it goes from one side of the Earth over to here. So our eclipse starts over in the Pacific Ocean, and it actually makes it over to Europe just a little ways. Not everybody in Europe will be able to see it, but they will be seeing it. Let's see, what time of day would that be? I guess they'll be seeing it just at sunset for them. Okay, it'll be the middle of the day for us, but for them, it'll be sunset.
We've got time for about 2 questions,
Okay.
and Dr. Bob will have Saturn in the.
Oh, nice. It cleared off.
Yeah.
Excellent, excellent. Yes, up front here, yes.
I got a couple of questions.
Okay.
What is the total effect, temperature-wise, over the whole, I guess, day when the eclipse is happening? Since it's dropping, you said about 10 to 20 degrees.
So, yeah, that 10 to 20 degrees is going to be right around totality. I mean, you'll be surprised at how bright it is when you've got, 5 to 10% of the sun still visible out there. I mean, you'll notice that it is darker, but it's not going to be incredibly dark out there. That little bit of sun, it puts out a tremendous amount of light, and also based on how your eye reacts to light, you've got to really, really, really cut down that remaining bit of sun to be able to see a noticeable change. So, you're probably not going to see or notice any temperature change up until maybe a couple minutes before or after totality.
Okay. And you've photographed the eclipse before, right?
The lunar eclipse.
Just the lunar?
Yeah.
Okay. I was just wondering if there's any recommended settings for...
There are a lot of websites by eclipse chasers where they say, okay, if you want to get this field of view, then I would suggest having these different settings on your camera. And there was also a recent article in Sky and Telescope magazine, I think it was last month, the August issue of Sky and Telescope, where they talked about photographing the eclipse and just some tips on that. It's not going to be, there's no one answer for it. I mean, some people say some things, some people say others, so you just kind of have to gain as much info as you can and make your best decision.
Thank you.
Gonna do one more question there. And you guys, if you have other questions, you're welcome to come up and talk with me. Oops, sorry, dude.
Well, that's the end of the presentation.
That's the end of the presentation, apparently.
How many eclipses have you seen, and what was your favorite one?
Let's see. I've seen a number of total lunar eclipses, but I've only seen probably about 4 or 5 partial solar eclipses. This will be my first total solar eclipse. But I think my favorite lunar eclipse was the one that I was showing you here, because we were at a really dark site, and we had I was with a lot of other friends, and they had telescopes, and so we were doing a lot of fun stuff during the eclipse, including taking pictures. I guess my favorite solar eclipse was the first one I ever photographed, and it was on Christmas Day of 2000. So it was, Christmas morning is always fun, so that just kind of topped it off. All right, so we're ready for Dr. Bob? Okay. So we've also got, again, these eclipse glasses, 1 per family. I think Porter and Alex will be up at the front. They will have these ready to hand out. We do, however, have a lot of these. We can make more of these very easily. We can't make any of these. So if you need 1 per family member for these, please be sure to grab one. All of this information is on our website, including these documents. And Alex has even set up a version of this where you can print off this information in 4 letter-sized 8.5 by 11 sheets. Okay, so if you need to send this to somebody or you need more copies, it's on the website as well, on the Eclipse page. All right. So yeah, if you have any other questions, feel free to come on up and have fun looking at Saturn.